Guys, Gunda Math over here, and this is the 2021 AMC 12B number 21. Here's a view of this problem. Let S be the sum of positive real numbers x, for which x raised to the power of 2 raised to the power of root 2 is equal to root 2 raised to the power of 2 raised to the power of x. Which of the following statements is true? So rewriting our equation over here, x to the 2 raised to the power of root 2 is equal to root 2 raised to the power of 2 raised to the power of x, and clearly indicating what we're taking to the power of, we get this thing, right? Now, the obvious thing to do over here is take a logarithm, and we have two choices for what to take. We can take log x, or we can take log root 2. Let's see what we like better. So taking log x, what do we get? Using basic power logarithm properties, this just gives us 2 raised to the power of root 2 is equal to log base 2 to the power of x times log base x of root 2. Okay, and what about taking log base root 2? What happens is we get on the LHS 2 raised to the power of root 2 times log base x, log base root 2 of x is equal to log base 2 to the power of x. Okay. So, which one do we like better? Me personally, I prefer when we take log base root 2, it's because we get a simple 2 raised to the power of x, which we can easily solve for x by taking log base 2 of both sides. Let's do that. So, x is equal to, and then we know that log AB is equal to log A plus log B. So, maybe doing that, we get log base 2 of 2 raised to the power of root 2 is simply root 2, and then plus log base 2 of log base root 2 of x. This is still pretty inconvenient, but if you'll remember another logarithm property, we have log base a raised to the power of m, b raised to the power of n is equal to n over m times log base a of b. And I encourage you to try to derive all these logarithm properties on your own. So doing that gives us x is equal to root 2 plus log base 2, and then root 2 is just 2 raised to the power 1/2, so we have 1 over 1/2, which is 2, and then we have log base 2 of x. Again, we can just simplify this as x is equal to root 2, and then splitting this logarithm will give us plus 1 plus log base 2 of log base 2 of x. Okay, and then maybe getting the stuff in one side will give us root 2 minus 1 is equal to log base 2 of log base 2 of x. And now what we can do is we can take a graphical approach, right? Because the LHS is really easy to draw, and the RHS is still relatively simple to draw. So drawing our Cartesian diagram, let's first draw the RHS. We get a convenient value. When x is equal to 2, this becomes 1 and the whole thing becomes 0. So we know that 2, 0 is on the graph. When x is equal to 4, we have 4, 1 on the graph. And then when x is equal to 8, we get log base 2 of 3 as the output, which is not super convenient. When x is equal to 16, however, we get 2. 16 and 2. Okay, so that's about enough here. We see that it will slowly grow, and then how about as x gets small, this gets very negative, right? So, like this. This is not the best graph, but okay, something like that. And then how about this one? Well, it has an intercept at negative root 2 minus 1, and then it'll gradually go. And as a check, let's see what happens when 2 happens. We have 1 minus root 2, which is negative. So we know up until 2 it goes under, and then it'll go like this, right? So let's try to find it. So we see that there are 2 distinct intersection points. Let's try to find one. Well, looking at the answer choices, right, we actually see some equality. S is equal to root 2. So let's just plug in root 2 into this. We get negative 1. Log base 2 of root 2 is 1/2, and log base 2 of 1/2 is negative 1. So that works, and that's actually an intersection point. Root 2, negative 1. How about the other one? Plugging in 4 into the RHS, we get 1, right? And plugging 4 into LHS, we get 3 minus root 2, which is 1.4. So this graph is actually inaccurate in the sense that at 4, our line is actually going to be above our log curve, right? Meaning that our other root is going to intercept the graph before x is equal to 4. So we have something before 4 plus root 2 that would land us in the constraint D, and we are done.